The broadcast is now starting. All attendees are in listen-only mode.
Hey, welcome everybody to Coffee with Caleffi. Hey, we're delighted today to have Jim Meseke. Did I get that right?
Yes.
He's the director of BIM Content at ENGworks down, and you're in the Chicago area. Is that where you're at?
That's correct.
Or somewhere. And he's been helping Caleffi. He's tasked with building all of our Caleffi objects and families. So I want to thank him, too, for coming today. I know this is a lot of work to pull one of these together, and I know he's crazy busy down there, so thanks for coming along.
Thanks, Bob. As Bob mentioned, I'm the director of BIM Content for ENGworks. And just a little background on myself, I've been in the AEC industry for more than 20 years. I've worked for structural and MEP engineers as well as architects and interior designers. I've been using Revit for more than 7 years and have been building MEP content since 2009. So today I intend to discuss and define what is BIM and also how do I acquire it and how do I implement it into my Revit project. And lastly, what separates Caleffi BIM content apart? So many of you have heard the buzzword BIM, but don't really know a lot about it. So if you are familiar with it, just please be patient, and I'm going to touch on some of the basic precepts. I will also cover both of the ways to obtain Caleffi content for Revit and show how they are going to be used in a sample hydronic system. And what sets Caleffi apart, there are many builders out there, you know, some of them are even experienced Revit modelers. However, building quality content takes an understanding of how the content needs to function within a building system. Building information modeling. So it's more commonly referred to as BIM. It's an object-oriented, virtually constructible 3D model with rich and intelligent data, allowing architects, engineers, and contractors greater control over the entire project. BIM software, like Revit, is based on data. It's database-driven, which allows the users the ability to alter the data sets at the component level and have those alterations update throughout the building model. So what is BIM and how does it differ from typical CAD? Well, first of all CAD is vector-oriented. Whether it's used for architecture or engineering, it's primarily just a grouping of lines to represent your design. Sure, you can set layers to differentiate disciplines and purpose, but at the end you're left with a static vector-based image. With BIM, the software controls the classification of objects because that's how they're defined. And there's intelligence embedded within those objects which can be used by engineers and architects to provide the users with information about the building model. A BIM project can also be shared amongst several users simultaneously, where a CAD file cannot. With CAD files, you need to open and close individual drawings as you work on them. With Revit, all of the views, schedules, legends, sheets, all that stuff is accessible from within the project browser. BIM models can also be linked together, allowing the different disciplines to access the building data. This linking also allows for coordinating between disciplines, minimizing collisions between system components. With BIM models being more robust informationally, they also require that a greater care be taken with the content used within the project. So how can I create a BIM model? Well, there's many software platforms out there which provide intelligent building models. Some of you may have heard of ArchiCAD. Bentley has a program called AECO Sim. For structural engineering, there's Tekla and Allplan for architecture, just to name a few. Today we're going to be focused specifically on Autodesk Revit. Revit holds the highest market share amongst the software platforms, but that's not the main reason why we're going to talk about it. It's currently the only platform out there which currently provides true system integration, meaning that the building components can communicate with each other to provide intelligent data for engineering design. So what is the value? Intelligent building models have several advantages. Number one, speed of design. Being object-oriented means the modeler is placing objects rather than drawing lines. Tagging objects for documentation does not require data entry as CAD does. The tags in Revit are linked directly to the components, so this ultimately increases the speed of production. Accuracy of data. Again, the flows are linked to the actual content and not just a text string with a leader. Building system analysis. Pipe and duct sizing can be analyzed more efficiently because the flows are apparent. Scheduling. Scheduling in Revit is almost automatic, and I say almost because it depends on the quality of content. If certain content is missing shared parameters, it just won't make it into your schedule. Collaboration. Simultaneous participation by the design teams, whether within the discipline or outside of the discipline. The collaboration effort allows multiple users to work on the same project at the same time. As the industry acceptance grows for BIM, so do the mandates by local municipalities and governing jurisdictions. Many countries now are already mandating BIM for construction. The UK is such, and I know recently Singapore as well. So the necessity for quality content. So as the community in BIM grows in number of users, so does the need for quality BIM content. And where does the responsibility lie when it comes to providing content? Well, not really from the engineers. They may have the know-how, but generally the project time constraints prevent them from providing the proper attention needed to build the quality content. Manufacturers of building components are the ones that really should be taking the lead here. Why? Well, number one, product familiarity. The manufacturers will always be the most knowledgeable about the products they create. Number two, maintenance. When product lines become available, one of the best ways to introduce them is to make the content available to the engineers. Lead generation. For the manufacturers, this is probably the most important. Getting your content specified in the schedule and bill of materials, it's imperative. The fact that it's there in the project during the design phase generally means that it will be there when it comes time to produce the bid documents and issue. Replication. Once an engineer has a model of a particular system and it functions, they're going to want to use that as often as they can in subsequent projects. The fact is the BIM system is functional. The fact that the BIM system is functional will increase that tendency. So what constitutes quality content? Number one, functionality. This is the most important thing that defines quality content. You can have 95% accuracy with the geometry, and the identity data is there for identifying the piece, and the proper parameters there for specification. But if it doesn't function in the model, the content is useless to the user. He's not going to use it. Number two, accessibility. can the user find the item that they're looking for, and does it load correctly? There are many different methods to which content can be obtained out there through bulletin boards and other content manufacturers' websites. But if it's not quality content, and sometimes you load something and you're expecting one type and you're getting something entirely different. Actually, in fact, the most common call I get for technical support are from users who can't find the content they're looking for, and then they get upset when they're the ones that did not load it properly. Ease of use. The user will be appreciative if they don't have to struggle to get the objects placed into the model. I mean, if in the case of Caleffi, if a separator is meant to be placed on a pipe, it should break into that pipe. It shouldn't have to struggle to make it part of the system. Flexibility. An engineer will frequently need to resize a component to an increase or decrease in flow calculations. Having content that flexes parametrically and can be quickly and easily modified within a project it's going to save time in production. Model weight. Some manufacturers just want to import their SolidWorks or Inventor models directly into Revit. Because why would they want to recreate the geometry if they already own it? The problem with that is when exported into Revit, the file size tends to balloon a bit for the family, you know, and it doesn't really sit well inside a project. You know, who cares, right? I mean, but at the end of the day, if you've got 1,000 instances of an item within a project, and they use the true geometry from SolidWorks, your regeneration time is gonna balloon. It's gonna increase exponentially. So what are the results? Well, having better content will allow the user the ability to improve production speed. Functional content will also allow the engineers to perform calculations and sizing easier. And when it looks right and functions right, users will want to use the products again and again. Okay, so now I'm going to be breaking off into showing the Revit program itself, and I'm going to go over a couple topics.
Should we, Jim, take any questions at this point before you jump in? Because I know you're going to jump back and forth between the different programs and screens. Anything, Woody, that comes up that might apply to the first handful of slides here before we, sometimes it's easier to answer them now, and then we get to the end and we forgot where we're at when they asked the question. So if there's nothing, we'll let you just jump right in. And it sounds like you're jumping.
Okay.
Well, hang on a second. Let me throw in a question at you here, okay? Just to satisfy that. Not all manufacturers' content is available. What do you do in this case? What value is the building information model for constructability if the geometry is inaccurate and if you're using placeholder content? Is this made up for in the bid in contingency?
Well, in the as far as when we build content, we primarily have the engineers in mind. So when we're building the content, we want it to represent the true size of the object. So using generic placeholders, although to get your system functioning, it is not a bad idea to use out-of-the-box content. But ultimately, when it comes time to for collision detection and to make sure that the actual content specified is going to handle your flows, it's best to use the custom BIM content produced by the manufacturer. Did that sort of answer it?
Yes, that's
I
fine.
think the goal is just to get the manufacturer on board.
Okay. Are there any other questions?
No.
Okay. So now I'm going to flash over to the Revit program and going to go over 3 items in particular. Number one is I'm going to give you a sample of a building system. Now it's a demonstration model, but I want to sort of explain what I mean by the flows calculating and the pieces talking to each other. The next part, I'm going to show you how to access the Revit BIM content from the Caleffi website. And then thirdly, our company creates a program that's a plugin for Revit called BIMXchange. And some of you may or may not be aware of this. But their Caleffi content is available through BIMXchange. And I'm going to show you how to access it and to load it into your projects.
Hey, that was good.
Yeah, so let's go into a sample hydronic system here. Well, actually, it's a sample entire project, really. And I'm going to use some components in here that are not necessarily all going to be hydronic components, but they sort of tell the story. So within Revit, primarily the reason why engineers like to use it is because of the flows, the ability to sum the total flows for a space. I mean, they're going to do their calculations on the size of the space, but when they start figuring the loads and size in the duct, a lot of that stuff can almost be automatic through Revit. So it all starts with the flows. In Revit, the flow data actually travels in the opposite direction of the media. And what I mean by that is that the airflow in this case is going to start at the air handling unit, and it's going to come down through the branches, through the VAV boxes, and be distributed out to the diffusers. Well, the flow of data in Revit is actually in the opposite direction. So Revit likes to start with the diffusers, and in this case, I have a single diffuser selected, and it's within the airflow of 230 CFM. So with a whole room populated through the diffusers, when I finally can get back to the VAV box and select it, it's going to auto-calc that. And right now it's showing that for this room I've got 1380 CFM coming to it. And similarly, when all the rest of the components are calculated, it's going to total the flows as it goes along and eventually get back to knowing, so that the air handling unit will know that the full load is on the system. So also within these things, so now I'm going to take a look at the VAV box in particular, because at this particular junction, this is where we're going to introduce multiple systems. So this is again why the quality BIM content needs to be there, because not only you got to handle airflow on the air side, but now we've got a hydronic component that you're introducing. In this case, the particular supply flow is going to be 3 GPM, and the return should also match that, and it does. And these flows then are going to similarly be traveling back, and they're going to be calculated as they go back to the source, the heating supply source, and you can see that they're also going to auto total. So again, that takes the guessing game about what the loads are on the components. And there's a sense of realism too, in that this box does represent the true geometry of the content, and also the flows then can also be calculated similarly. So now what I'd like to do is to move over to a sample hydronic system. I'm going to pull out specifically the hydronic system here. As you can see, I have a sample of VAV boxes here used. And again, like I mentioned, these particular components, they need to have the ability to work in multiple systems simultaneously. So I could draw a duct from it and connect it to a supply air system and such. But today what we're going to do is we're going to be focusing primarily on the hydronic components. So within the VAV boxes, I call them for an airside system, a VAV box is going to be kind of a middle component, meaning that it's got the calculations, it's calculating from the diffusers, and it's taking through the supply air, and it's going to push it down or upstream all the way back to the air handling unit. So, and for the air supply, or for the air system, it's going to be in the middle. But for a hydronic system, it's really an end component. And what I mean by that is, it's the end component is going to be the one that this component is going to determine the load on the flows for the hydronic system. In this case, this particular heating flow is set to 4 GPM. And so we have the supply down here set to 4, and similarly the return is also going to be set to 4. And what that's going to do is that when these things are connected in tandem, it's going to total. So I should have 8 down here, and I do have 8. So and please excuse the rudimentary design here. I know there's a lot more building components that are going to go into a hydronic system design, but this is just to represent how a typical system is going to work. So at the end of the day, when it comes to using the systems or designing the systems, Revit will have the ability to auto total the flows and get you the demand load going into each one. So now I'm going to introduce the Caleffi Revit content, and I'll talk a little bit about, in particular, in this case, the hydraulic separator, the 548, because how this is going to differ also from some components made by other manufacturers is that we have a true understanding of how this piece wants to function within the system. In this case, we have 2 systems set up to go through the same piece. We have the primary system, which is the heating water supply, and then the secondary system, which is the distribution to the VAV boxes. So in many cases, what people do is when they're building the content, well, they'll take a piece like this and they'll put the connectors on it, and yeah, you can draw pipe from it and you can snap into the project. But what generally happens is the flows try to go straight across. So whatever you have set up as a system from the heating supply, it's going to be equal to the distribution supply, and that's not the case in reality. So what we have here is within the Revit content for Caleffi is the ability to separate the systems. So in this case, we already talked about the distribution side, the secondary side being 8 GPM, and from supply and return, it's set to 8 GPM. But on the supply side could be something totally different. In this case, I have it set to 30. And the return is also to 30. And those are also going to be factors that are determined by the end system here, end system units being the boilers. So I'm going to go ahead and select the boilers at this time, and I'm going to change the water flow here from 15 to 14. And just to show that these things will automatically update within the system. So now I've got 28 GPM, and whether this is realistic or not is not the point. It's just to show how the system's going to work. So both the supply and return for the primary system is set, but the secondary system, it doesn't change the values from that. In order to change from the values for the distribution system, I'm going to have to go back to the VAV boxes, and I'm going to select those, and I'm going to go into the heating design heating water flow, and I'm going to change that. I'm going to knock that down to 3, and you can see right away also that the flows then also change downstream. Now, also in between here, you'll notice that we have some balancing valves here. This is the case, the Caleffi 121 flow cal, and also a zone valve, the Z1 valve with automatic actuation on his. And now what I wanted to show also here too, so The other component I mentioned of BIM is the ability to find out more information about the pieces. Scheduling is one thing, and I'll go into that in a short time. But if I take a glance at any of the components and select them, you're going to get information about this. The constraints are the dimensional information on which controls the geometry. But here you're going to get to see even some of the engineering criteria that the engineer is going to need to know, like what the minimum and maximum operating temperatures are, connection size, unit weight. In this case, well, 0 kips, but that's because my project is set to kips. But also come down to the identity data, and here it has links that go directly back right to the product, provided it gets there. There we go. So you can find out information here. You can go to the technical brochure. You can get the spec. You can download the submittals, whatever you need. But you can access this data directly from the actual building model itself. You can also, if you have any questions about the content, there's also links that get back to Caleffi and allow you to contact them, apparently no matter what country you're in.
Yeah, you can go right to Italy there.
Yeah, that's nice.
The trip on BIM.
Yep. So that's just one of the other added, features that separates BIM from traditional drafting. Okay, so now I've shown how these items work within the system, but I still haven't answered how do we go ahead and get the components and how do we load them. So what I'm going to do is I'm going to go actually back to the website. From the Caleffi website, you can search any of the products, or if you know exactly what you're looking for, if you're looking for any type of separator. In this case, I already did a search for the NA548. And you'll see over here that there's a link for the BIM 3D CAD. And that's going to, one click, and it's going to download it. So I'm going to go ahead and open up this particular one and take a look at it. So when you download it, it's very important that you need to extract this to a local folder. The reason is that Revit content cannot be loaded directly from within a zip file. The Revit content here is it's an RFA file, which is a Revit family, and the TXT file is the associated type catalog. So what we're going to do is that we're going to load this into the Revit project, and I'm going to do that from going Insert, Load Family, go to the 548. Whoops. Excuse me, if whoever has the music on, could you please hit mute on that, or mute yourself? Thanks. Okay, so after selecting the file from the library, actually let me go ahead and do that again. I'm going to load the family. I'm going to navigate to the folder where it's at, and I'm going to select the item to load. So when it's properly extracted, in other words, when the TXT file is in the same folder as the RFA, you're going to see a window pop up, and this is called the type catalog. We generally usually try to have the engineering criteria come into the first couple columns, so you can quickly know the item that you're going to need to select. You can select it based upon the engineering criteria. So you physically have to select them. And in this case, I'm just going to load them all, so we have them in the Revit model. Okay, and once loaded, you can simply place the objects into your project. And the other thing too that separates BIM from CAD is, okay, so if you need to, I was mentioning, engineers frequently need to resize these based upon the loads that are or the demand on the system. So with Revit, you can simply just select the larger type, and each of the elements that you select you can get the information on what their flow rates are intended to be at specific at specific velocities, as well as the CV coefficient, which is going to be used in your flow calculations. And here we're seeing the unit weight show up because it's bigger than the other items. So that's one way that you're going to be able to access the Caleffi Revit BIM. Now I'm going to show another way that we can access the BIM. Currently, we have there's an add-in that our company manufactures called BIMXchange. Now this is a free plugin, and it's available on our website. And I'm going to go ahead and load it. And when you do download it and install it for your system, to access the content, you simply hit change catalog, and this gives you a spot for you to enter the access code. Now this is a one-time enter for the access code, and it's based upon the code for Caleffi. So whether it depends on which version of Revit you're using, and it's one code for all of it. So once you enter it, you can access then the Caleffi content. So in this case, not the entire catalog, we're working on that, but you'll see that it has a good cross section of elements that are available, and I'll show you how those work. Again, the reason to use the add-in is it works inside of Revit, so you don't have to leave Revit to go and acquire the content. So if you are looking for a freestanding separator, in this case the freestanding the NA546, you can go ahead and you can select this. Now I have several different options here. The down arrow will load the piece directly into my project. I can go ahead and click on this, and it's going to go ahead and load it into the project, and it's going to give you the information that it has. So I'm also going to go ahead and I'm going to select another component. Yeah, any of these. And there's a box here with the T in it, and that's going to bring up the type catalog. Same thing that you saw when you were loading it manually, but this is going to allow you to go ahead and select different components and load just the ones you need. And again, hitting the down arrow will load them directly into the project. Once loaded, then you're able to place them directly in the project. Well, in this case, it would snap onto a pipe. I don't have a pipe that's going to snap onto, but you get the picture. So one of the other things too that I also want to go through is, okay, so now I've downloaded it and I've loaded it into my project. Now, how am I going to use it? So what we have is I want to just show a couple samples of how these things are meant to be used. I had already spoken about some of the elements that are designed in case to break into a pipe, to load directly onto a pipe. In this case, the 551 air separator will do just that. So if I go ahead and grab one of these and select it and then drop it on the pipe, it's going to automatically cut directly into the pipe. So you don't have to guess about, is it on there, is it aligned, is it at the right height? It just drops right in, and you're able to use it.
It also corrects it that it's a flanged version of that too, so it put flanged on the pipes. It knows that particular model requires companion flanges, and it put those in there too, which is really clever.
Yes, that's actually a part of the pipe. It's defined by the pipe type. In this case, I have a flanged pipe type, and that's, so I hope when I draw this one, it'll show the proper pipe type. So the other way to do this, the 548, as I demonstrated before, since it has two systems, this particular one is not a breaks into, so you cannot drop it directly on a pipe. I mean, you can, if you had a pipe, and let me go ahead and draw one. Let me repeat that.
So what you're saying, Jim, is it knows that it can't go onto that 4-inch pipe because it's a 2-inch separator, basically.
Correct.
Yeah.
But what you can do is you can drag it onto a pipe. Oops. In this case, it went to the wrong side. But then once it's on the pipe, oops, it's not even on the pipe. Let's try this side. Okay. Once you drop it onto the pipe, then wherever you move the pipe, the item's going to go, and similarly, wherever you move the separator, the pipe is going to go. The other thing too that you see here is that it's already recognizes that because of the way that the connectors are set, that this is part of a heating water supply system. So if I go ahead and draw a pipe from this one, you're going to see it already knows that, hey, if this is the supply, this is going to be the return. And the same thing from the secondary system. It's going to know the supply, and it's going to know the return. You'll find out there in the market where there are other BIM content pieces that are separator set. You're probably not going to find very many that function like this. Again, it comes from years of creating the stuff, as well as collaborating with our in-house engineers, because we're not only content builders, we're a full-service MEP engineering firm. So we not only build the models, but we need to make sure that they function. And if they don't function for us, we're going to assume that they're not going to function for others. And as well, I have the freestanding loaded, and that's actually, let's get the proper pipe type. It's going to load and connect the same way.
That's pretty impressive.
So that's primarily it as far as the Revit presentation goes. Are there any questions while I'm still in Revit?
We'll give Woody a minute to come on. He's usually muted, but he's monitoring questions. We'll see what we can give you while we're...
Well, I'll just, here I am. I'll kind of go to the top here and see what I can tell you. Here's one. In my experience, manufacturers usually have both CAD models and Revit families or nothing at all. Do you think those manufacturers that don't have those things available will catch up in the near future?
Well, if they don't, they're going to be left behind. We've been making Revit models for over 9 years now here at ENGworks, and we know that some of the we'll build one company's Revit content, and then it doesn't take long for their competition to give us a call and say, hey, wait a minute, you guys are destroying us, because other people are using your content and it's getting specified in projects. So yeah, I hope that that the rest of the manufacturers are going to catch on and realize they're going to need Revit content.
Okay. How do you correct snap a 3D diffuser object into the correct exact ceiling grid location?
Oh, okay. Well, that one is going to depend on how the content is built. I don't think I have a ceiling grid on this particular model that showcased earlier. But if it's a face-based model, in this case, this one is, the face-based will simply, if I go ahead and similar, it's face-based meaning it's looking for a plane that needs to be inserted on. So whether that's a work plane or the face of a ceiling, you actually have to be in a reflected ceiling view to place it, and you can go ahead and place it directly on that face. After that, aligning these objects should be fairly easy, and I'll try and demonstrate that. I'm just going to draw a simple detail line. I could draw a reference plane as well, but I should be able to align an object to that simply like that. So when you see a ceiling grid aligning BIM objects, it becomes a snap. You're just able to align it, and it'll appear that way. So
Okay.
let's see if we can take a look at that. There is one other thing I did want to mention too, and it was kind of a big component of that I had mentioned earlier, is scheduling. Okay, so we have all these pieces in our project, and one of the benefits of Revit is the scheduling is automatic. Basically, if the units are in the project and they're displayed in the system, if they're actually placed, well, then they're going to be counted by the schedules. So I've created a sample mechanical equipment schedule. Now let me load that right up. So in this case, it's giving us that we have a couple of inline pumps, and we have 4 inline pumps, 3 boilers, 2 terminal units for the VAV boxes. But it's also giving us a list of the components that are placed in here. It's going to give you the counts automatically. Now, obviously, those engineers out there know that there's going to be several different criteria that you're going to want to set up in your schedule, and that's all. Those fields are editable, and so long as the parameters are shared, you're able to add any of these fields, like a location field of what room it's in. Let's see, you can get to any of the engineering criteria that you wanted to add in there. You could do that. You can do that separately. So again, like I was mentioning, so the fact that these make it into the schedule is likely that they're gonna live in that in the project all the way through to bid documents are produced. So I have for this one, and not only that, but the pipe accessories schedule. I've also created a sample one of those, and you can create many different schedules for all the different components that you're going to need for your project.
Okay.
So I just wanted to show
how
that works.
Nice. Okay, here's another one. Do you see Revit becoming the standard over CAD in the near future, or will CAD always fill a niche role in this market?
Well, it's an interesting question. It's moving forward for design and documentation. I do see Revit taking over eventually. Right now, I don't know the exact number on what the market share is on Revit. I know it's not as high as AutoCAD, but it's quickly catching up because people just don't want to do it the old ways. They want the information, and like I mentioned before, sometimes it's required by municipalities, jurisdictions, wherever you're building your project. But CAD will also always have a place, and I don't want to say that that CAD is not going to be useful, because for those engineers that have drawn thousands and thousands of details, in the past number of years, you're going to be able to still utilize those details. You can set them up as drawing families within your project, the detail families, detail items, so that you can load them as views and still place them into your project. So all is not yet lost when it comes to those. They can also be dynamically linked into your project. You can link CAD files into here, and that's typically done for example, if you're an engineer working on a project and the architect has only provided 2D CAD drawings. Well, it doesn't mean you need to stop with your engineering design in 3D. It just allows you to link their CAD files directly so you can continue your work.
Okay. Here's another one. Let's see. Does the program automatically size the pipe based on calculated flow, or does the designer have to do that? And does it know the difference between metal piping components and plastic and the allowable vehicle velocities for both?
Okay. Yes and no. Let me just answer the first question. I think first. So, will the pipe automatically size? No, not necessarily. But if we were to take any component and place it, and then choose a larger component, the sizing for the piping you can see here is listed as 2 inches. If I were to select actually, let me see. This is a unit inline, so if I select a smaller unit, in this case, the piping size is going to pop down to 1.25 inches. But the engineer still, it doesn't take all the thinking out of the project. The engineer still has to do an analysis. Revit does allow you to do that, to analyze the building systems. So you can do heating, cooling loads, well, you can see it, duct pressure loss report, check piping systems, and show disconnects if there are any in the system. So it does allow you to analyze these things, and you can have, there's also the energy analysis I was mentioning as far as the sustainability and the moving forward, and a lot of the LEED requirements that are important for building today. So you can, it doesn't size it automatically, but it will. You can set it to even warn you, or even do an analysis on it, letting you know that you need a larger size for your system.
Okay.
Can you repeat the second part of that question?
Let's see if I can get to it here.
Different types of pipe. I think you said plastic or something.
Oh yeah, plastic or metal.
Oh, okay. Yes. No, Revit doesn't. In fact, it's in this case, this is a it's going to be a union inline. It's not going to. It wouldn't use a flanged pipe, but if I were to go ahead and draw pipe, and then select a flanged size and put it on there, it will likely. Oh, in this case, no flanges are available for 1.25 inches, so that's good. But it would place a flange size. So Revit doesn't actually know the components that you're using and whether or not you're using plastic pipe versus metal pipe. Again, it's not dummy proof. You still need to be able to know what types of pipe that you're connecting to which systems. Certain systems are defined under the piping systems as, well, in this case there's only 3, but they're typically, the pipe types are usually defined as like hydronic supply, or domestic hot water, domestic cold water, sanitary, what have you. And then you're gonna apply this, whether the pipe is plastic or metal or PEX or any of those within the properties for the pipe types.
And that could be built into the library, like if this a PP type of pipe is coming out, that manufacturer could have you build the BIM files. That pipe would be in there then.
That's correct.
Yeah.
Okay, I think we'll just do one more. It's kind of a nice point that's been made here. Speaking from the general contractor's viewpoint, architects and engineers frequently state that BIM requires more time to complete, and engineers frequently state that BIM requires more time to complete their drawings, but use of BIM modeling, however, will result in less RFIs and change orders if the drawings are coordinated before they are sent out. So can you speak to that?
Right. Well, sort of another two-parter. The first part is that architects and engineers, if they generally are saying that BIM models take longer to create, then and I don't want to say that sometimes they don't know what they're doing, or they might be relatively new to the BIM world, but they shouldn't take. We've noticed a considerable decrease in the project time by switching to Revit for our projects, and just because of the fact that I can draw pipe quickly, laying out pipe runs automatically, in any direction I need. It's just like drawing lines. But more importantly, it's going to depend on the user's knowledge and how efficient they are in it. The second part of the question was in the RFIs that do come through, for when they do have collisions. And again, with Revit, you do have the ability to, and I think it was under the analyze. There is a collision detection. Where's it? Collaborate. That's where it is. Interference check, they call it here. What many people do in the AEC industry is they'll export their models to a program called Navisworks, which is it basically dumbs down the geometry. You lose all of the flow data, but you get to see kind of a cartoonish version of your piping displays, and that will actually go ahead and analyze clash detection. I mean, that's what the program Navisworks is. But that's a whole separate webinar.
Right. Okay, we're getting close to the end here. I just want to address one more thing, is that yes, copies of this webinar are going to be available. Bob can address that issue, and there are other questions that we couldn't get to here, but every one of these we will be answering individually. So I think that does the question period.
Okay, let's get back to where we left off.
Yeah, this was great. I mean, I don't know a lot about this, but this was a real, I think you presented the material in a really understandable method. I know there's a lot to it. I mean, an hour doesn't leave you a lot of time to get everything out, but I think you hit it. You did a great job. Thanks.
Great, thanks. So just to recap quickly, the benefits of BIM are the ability to conceptualize your design, to visualize it in a 3D environment, the ability to analyze the systems and their flows, and to be able to then document this similarly to the way you would do it in CAD. The documents are actually extracted from the model rather than drawn. Fabrication, BIM carries itself, the BIM model will carry itself not only path design and through the bid process, but when it actually comes time to building a fabricated model, contractors, general contractors, generally they will hire subs for each, and each sub is going to be required to build the model for those disciplines. So it's going to, the actual BIM model will live longer than the design phase, and that coordination process is going to be handled throughout the building stage. And lastly, and I didn't really touch much on this one, but BIM models will live through the life cycle of a building. From after they're created, they're going to be used by the engineers and building engineers. And when a piece of equipment fails, and they need to know, well, what is that equipment? Who makes it? Where do I find it? And if that company is gone, is there another company that I can use? All that stuff can be gleaned from the building information model. It's done correctly.
Okay.
Lastly, as I mentioned, acquiring BIMXchange. Again, it is an add-on for Revit, and you must install it. It is available. It's free and can be downloaded at the website you see below. And for those that want, they can. Well, they'll get a copy of this webinar, and that link will be in there, along with the Caleffi BIM BIMXchange library access code. So again, if this will be available to the users to download, you'll have all the information you need to get BIMXchange up and running, and so that your Revit projects are going to run faster and smoother.
I guess just a thank you to everybody once again for tuning in. We had a great crowd today. I think we had 300 people signed up, so hopefully it was something that is of value to you. Let us know either way, and we'll see you on the next one. Thanks, team. Thanks to everybody that supported us on the back end there also.